We noted that human population growth is not uniform over the globe. Some regions of the world are growing much faster than others. In fact, many of the regions with the fastest growth rates are also regions that are the least able to cope with the growth. Notably, some of the lesser developed regions of Africa, Asia, and Latin America have very high growth rates. As we mentioned in Week 1, this fact led early environmentalists in the 1970s and 80s to blame many of the looming environmental issues on these countries' rapid growth. We know that's now only part of the story, and we'll address this again later in the lesson. According to the United Nations Department of Economic and Social Affairs, the following 10 countries will add the most people in the next 40 years. You can see that 9 out of the 10 countries are developing countries, many of which already have some serious environmental, social, political, or economic issues. Actually, the United States is the only developed country on the list. What's up with that? Well, there are several reasons. First, we have higher birth rates and total fertility rates than most of the other developed countries. Also, we have a younger age distribution than many of our peers. Thus, a higher percentage of our population is in reproductive years. And then, probably most importantly, we're simply huge to begin with. So even a small percentage increase in population means a very large increase in actual numbers. Students often ask about immigration. Isn't immigration the reason for why our growth rates are so high? No, not really. It's true that we lead the world in terms of the number of immigrants that come into our country, though that might change. But if you look at immigration rates, there's many countries that have higher immigration rates per capita than we do. We're a large country. The number of people that are immigrating in is a very, very small percentage of our total. And as such, it doesn't have as big of impact as you might expect on our growth rate. Let's look at growth rates. The growth rate of a population, which is always abbreviated with a small r, is the percent increase of that population over time. Here's the growth rates of a few selected regions and countries around the world, as taken from the United Nations Department of Economic and Social Affairs website. I encourage you to check out that website. It's very interesting. Anyway, you can see the United States growth rate is 0.75%, which is slightly smaller than North America as a whole, which just tells us that Canada has a slightly higher growth rate, much larger than Western Europe, and much, much larger than Eastern Europe, where populations are actually in decline. In Eastern Africa, we see a much higher growth rate, about over 3 times as high as the United States. In fact, Eastern Africa is one of the fastest growing regions of the world. Here's the United Nations website, an amazing amount of data right at your fingertips. I'm going to go to interactive data here. You can see there's all sorts of things that you can check out. Population, fertility, mortality, migration, age distribution, etc. For that example that I showed previously, I looked at growth rates. You can choose regions of the world, any countries of the world, etc. Or you can choose the whole world. You can choose any particular dates. I simply chose 2010 to 2015. And there you go. You can see that the less developed regions of the world here are growing at a rate of 1.36% compared to the more developed regions, those 0.29%. You can divide it by income of the country, or you can look at specific countries. Interesting stuff. I encourage you to play around with it. So how do populations change in size? Why are some countries' growth rates higher than others? Well, in a closed system, for instance, if we were to consider the whole Earth, a closed system means that there's nobody coming in and out. So the whole Earth would be a good example. No one's coming in from outer space and no one's leaving to outer space. A very isolated country might have a closed population as well. In a closed population, all you have to deal with are births and deaths. So the growth rate is calculated by simply taking the birth rate and subtracting the death rate. For open systems, that's most countries of the world, where people can come in and out freely, you also have to deal with immigration and emigration. So the total growth rate is still birth rate minus death rate, but you also have to add in immigration and subtract out emigration. So that simple growth rate number that was shown on the United Nations website had a lot involved in it. They had to have birth rates, death rates, immigration rates, and emigration rates for all the countries that were listed. In the United States, we do have more immigrants coming in than immigrants leaving, so immigration does have a net positive effect on our growth rate. But the primary effect of our growth rate is that our birth rate exceeds our death rate. And if birth rate exceeds death rate, unless you have a whole lot of emigration, you're likely to have a high growth rate. Let's consider China. This is the country profiled in Chapter 4 of your text. China's standard of living improved greatly in the second half of the 20th century. Life expectancy increased dramatically. The death rate fell, but the birth rate held steady. So just looking at that equation previously, if the birth rate is holding constant and the death rate is falling, you can expect there to be an increase in the growth rate. And that's indeed what happened. Mexico experienced a similar phenomena in the early 20th century. You can see that death rates declined dramatically, but birth rates remained fairly high and steady for several decades after the death rate plummeted. This led to huge population growth. In the 1950s, Mexico's population growth rate was over 3%. Notably, the birth rate has continued to go down even since this graph was published, and currently Mexico's growth rate is just over 1%. This phenomena of death rates dropping first before birth rates is fairly typical, and it's modeled by demographers by something called the demographic transition. The demographic transition is a model that describes the expected changes in birth rates, death rates, and overall growth rates as a country develops. Here's a picture of the demographic transition, and we're going to go through it step by step. Here's the diagram from your textbook. Notably, though, first we should say that the demographic transition was created based on observations made during the industrialization of Europe. The developed countries, including the United States, Japan, and many of the European Union, seem to have followed these stages, and it's assumed by some that developing countries today will follow them as well. Though maybe you can figure out some reasons why this model may not be as effective for some of the developing countries today. All right, so you can see that there's 4 stages: pre-industrial, industrializing, mature, and post-industrial. And that there's a light blue line, which represents birth rates, and the dark blue line, which represents death rates, and then the green line, which represents the total population. First, let's look at the pre-industrial stage. Birth rates and death rates are both very high, but since they're both very similar, the growth rate is low and population growth is very modest. The total fertility rate and infant mortality rate are probably both very high, and famines and plagues and wars may also increase the death rate. Check out the graph during stage 1 and note the high birth and death rates, as well as the very low population numbers. Next, stage 2. As the society undergoes industrialization, the death rate decreases dramatically due to improved health care, improved sanitation, and more reliable food and water supplies. The birth rate, however, stays more constant. It drops a little, but nowhere near as much as the death rate. Since the death rate has dropped, but the birth rate remains high, there is rapid population growth. Next, check out stage 3. At this stage, birth rates significantly drop. This drop is due to cultural and economic factors related to the economic development. Good health care is available, so infant mortality drops, and couples do not need to have many children in order to ensure that some make it to adulthood. Additionally, a greater percentage of the population lives in urban areas, and the pronatal pressure for agrarian labor is diminished. Further, there's more access to education, which generally leads to higher marriage age and couples waiting later to start a family, and thus generally they have fewer children. As birth rates drop, growth rates decline, and population growth begins to slow down. Lastly, check out stage 4, post-industrial. Here, both birth and death rates are very low. In general, people are more highly educated and more affluent. As there's more women involved in higher education, the average age of childbearing rises, and thus family sizes are smaller. There's a cultural shift towards smaller families, and families take steps to limit their family size. Population growth is slow or even absent. In fact, some populations may even decline in size. So that's the demographic transition. You can think of how it applies to countries today and to how it may not apply as well today. Also consider China. What's happening in China, or maybe what happened in China. Your book profiles China and noted how they came up with strict laws in order to try to limit birth rates. Some people would argue that China would have undergone the demographic transition even without those laws enacted. What do you think?